Well, today we'll discuss on Physics Grade 11, Chapter 4, Dynamics. 50 multiple choice question based on Grade 11 Physics, Chapter 4, Dynamics, completed with solution in clear situation. This we will discuss question starting from question number 1 up to 50. So when we start from the beginning, question number 1 says that a box rests on the frictionless horizontal surface. A horizontal force of 10 Newton is applied. What happened to the box? A. It remains at rest. B. It moves with a constant velocity. Choice C. It accelerates in the directions of force. Choice D. The accelerate is opposite to the force. When we come to the idea of this one, according to the Newton's law of motion, the applied force is 10 Newton on a given something. So from this one, the correct answer is C, means situation. Newton's second law said net force causes acceleration with no friction. So the 10 Newton force produces the acceleration. The next one, question number 2. Question number 2 said that a 5 kilogram object is acted on by an net force of 20 Newton. The acceleration is A, 0.25 meter per second, B, 4 meter per second square, C, 100 meter per second square, D, 15 meter per second square. When we come to the idea of this about the equation, according to Newton's second law of motion, if there is a given force is applied, that force is unbalanced, it accelerates in the directions of the applied forces. So the correct answer is B. B says that situation acceleration is equals to force or net force over mass of the object, which is equals to 20 Newton over 5 kilogram, which is equals to 4 meter per second square. So the correct answer is B. Third, question number 3. A car moves at a constant velocity in a straight road. The net force on the car is A, in the directions of the motion, B, opposite to the motion, C, 0, D, equal to the weight. From the given this one, the applied force is what? The applied force is on object, and that object is moving with a constant velocity. So according to Newton laws of motion, the correct answer is C. C says that situation, Newton's first law, a constant velocity, which implied that 0 net forces. So the correct answer is C. Question number 4. A book is pushed with 5 Newton rightward and friction force pulls leftwards with 2 Newton. The net force on this one is A, 3 Newton left direction. Choice B, 7 Newton right direction. Choice C, 3 Newton in right direction. Choice D, no, 0 forces. From the given this one, the applied force is 5 Newton and the frictional force is 2 Newton, which means frictional forces act in the opposite directions of the applied forces. From this one, when we subtract the frictional force from the applied forces, as I try to showing on the screen, 5 Newton minus 2 Newton is equals to 3 Newton to the applied forces, which is so the correct answer is C. Question number 5. An astronaut throws a tool in space away from the spacecraft. The astronaut will, choice A, remain stationary. Choice B, move toward the spacecraft. Choice C, move opposite to the tool's motion. Choice D, move with the tools. The correct answer is, from the given this one, the applied forces from the applied forces on this one is what? On what? The forces applied from the astronaut on the tool. So the tool is what? Acted in a given direction. So the correct answer is C, situation. Newton's third law of motion states that about action in the reaction when astronaut experiences equal given forces on a tool, that tools also exerted equal force in opposite direction. From this one, astronaut experiences equal forces. The third or the next one or question number 6 says that which law explains why a passenger launches forwards when the bus suddenly stops? Choice A, first law. Choice B, second law. Choice C, third law. Choice D, laws of gravitational. From the given this one, when we come to the ideas of what Newton's law of motion, Newton's first law of motion is given, Newton's second law is also other. So according to the given this one, the passenger is in a car, suddenly the car is stopped. So the directions of the motions of the passenger is from the given this one. The correct answer is choice A. A say that the first law, inertia, which is first law, passengers continues moving forwards while the bus stops. The next question or question number 7. Question number 7 say that a force of 15 Newton accelerates a 10 kilogram block from the rest. The velocity after 4 seconds is given. Choice A. 12 meter per second. Choice B, 4 meter per second. Choice C, 0.75 meter per second. Choice D, 4 meter per second. From the given this one, we know the applied forces. The applied force is what? Once wait me. From this one, the applied force is 15 Newton. And the object is what? 10 kilogram. So from this one, to calculate the acceleration, simply we divide the applied forces on the mass of the object, which means 15 Newton divided to 10 kilogram, which is equals to 5 meter per second square. From the given this one, acceleration is the ratio of velocity over what? Time. So from this one, final velocity is equals to acceleration times times, when we insert the given value, 5 meter per second times 4 seconds, which is equals to 20 meter per second. The next question, question number 8. A 2 kilogram object has a net force of 8 Newton acting for 3 seconds. Changing in velocity is, choice A, 12 meter per second, choice B, 4 meter per second, choice C, 0.75 meter per second, choice D, 24 meter per second. From this one, we have acceleration is what? Simply the ratio of what? Force over the time from when we insert the given into the equation, 8 Newton to what? 2 kilogram, which is equals to 4 meter per second square. So from this one, the difference between average velocity is equals to acceleration times time, which is equals to 12 meter per second. Question number 9. If a mass is doubled and the net force is halved, acceleration becomes, choice A, 1 over 4 original, choice B, 1 over 2 original, choice C, the same, choice D, 2 times original. From the given situation, the correct answer is A, means from this one, acceleration is equals to the applied force over mass, which is equals to the new acceleration is force divided to from this one when we insert the given into the equation. Finally, the applied force over 4, which is equals to original divided to what? Force means 1 over 4 the original. The next question, question number 10. Question number 10 is say that question number 10, 2 force of 5 Newton, 6 Newton east and 8 Newton north acts on an object magnitude of the net forces. According to the given this one, the choice A says that 2 Newton, choice B 10 Newton, choice C 14 Newton, choice D is 48 Newton. From this, to calculate this one, we have to use the Pythagoras theorem. C is equals to C square is equals to B square plus C square. When we insert the given value into the equation, the correct answer is what? The square root of 6 plus the square root of 8 is equals to the square root of 100. Square root of 100 is equals to 10. From this, the correct answer is B. When we come to section 4.2 about frictional forces. Question number 11. A 10 kilogram box on horizontal floor has the coefficient of static friction, which is equals to 0.4, and the coefficient of kinetic friction is equals to 0.3. The maximum static friction force is choice A 98 Newton, choice B 29.4 Newton, choice C 39.2 Newton, choice D 49 Newton. So when we come to the answer, this one, the correct answer concerning about this one is what? C. C says that situation, the static friction is maximum, which is equals to the product of coefficient of static friction times normal force. From this one, normal force means simply it is what the product of mass of the object times gravitational field strength is. When you insert the given value into the equation, mass of the object from the given this one, it is equals to what? 10 kilogram, and gravitational field strength is 9.8 meter per second square. The product of this coefficient of static friction times mass of the object times gravitational field strength is equals to 39.2 Newton. So the correct answer is C. The next question. Question number 12. Sum box as question 11 above. If pulled with 13 Newton horizontal forces, frictional force is 39, choice A 39.2 Newton, choice B 13 Newton, choice C 29.4 Newton, choice D 0 Newton. From the given this one, the situation, coefficient of static friction, coefficient of force of friction is maximum, which is what? Coefficient of static friction, which is equals to 13 newtons. The next question, or question number 13. Same box pulled with 15 Newton horizontal forces, kinetic friction force is choice A 39.2 Newton, choice B 50 Newton, choice C 29.4 Newton, choice D 98 Newton. So when we come to the correct answer concerning about this question, the situation, coefficient of kinetic friction is equals to force of kinetic friction is equals to the product of coefficient of kinetic friction times normal force, when the normal force is simply the product of mass of the object gravitational field strength. Inserting the given value into the equation, 0.3 times 98 is equals to 29.4 Newton, which is what? Constant once the object is moving due to this what? Kinetic friction. The next question, question number 14. A box slide is on icy low coefficient of friction completed at asphaltis. IC has choice A higher coefficient of static friction, choice B lower coefficient of static friction, choice C the same coefficient of static friction, choice D no friction. From the given, we comparing the coefficient of static frictions of IC with what? Asphalt. From the given this situation, the IC has much lower coefficient of friction. So the correct answer is B. The next question, or question number 15. Question number 15 say that a 5 kilogram block on horizontal surface has coefficient of kinetic friction which is equals to 0.2. Friction force when moving at a constant speed, choice A 0 Newton, choice B 9.8 Newton, choice C 49 Newton, choice D 1 Newton. When we come to the solution for the above question situation, coefficient of force of kinetic friction, here F is what? Represent the forces, and the K small is what? Represent coefficient of kinetic friction. Coefficient of force of kinetic friction is the product of coefficient of kinetic friction times mass of the object times gravitational field strength. Here, the coefficient of kinetic friction is 0.2, means it is given, and the mass of the object is what? 5 kilogram, and the gravitational field strength is 9.8 meter per second square. So the product of this one is approximately 9.8 Newton. So the correct answer is B. The next question, or question number 16. A 200 Newton creates on a floor with coefficient of static friction is equals to 0.5. Minimum force to start moving this object is equal to, choice A, 200 Newton, choice B, 100 Newton, choice C, 50 Newton, choice D, 400 Newton. From the given this one, we asked the situations, the force of static friction, the maximum force of static friction is simply the product of coefficient of static friction times the applied forces, which is 0.5 times 200 Newton is equals to 100 Newton. This is what the correct answer is B. B says that 100 Newton. The next question, or question number 17. If normal force is doubles kinetic energy, choice A, halves, choice B, doubles, choice C, stays the same, choice D, quadruples. From the given this one, when we comparing the normal force and the kinetic friction situation, coefficient of kinetic friction, force of kinetic friction is equals to the product of coefficient of kinetic friction times normal force. Due to this one, it is directly proportional to the normal force. So the correct answer is the correct answer is what? B. B says that doubles. The next question, question number 18. Rolling friction is generally dash slide frictions. Means when we compare this roll friction with what? Slide friction, greater, choice A, greater than, choice B, less than, choice C, equal to, choice D, and related to. When you're comparing the rolling friction with what? Sliding friction, the rolling friction is much smaller than sliding friction. Sliding friction is greater than the rolling friction. The reverse of this. The next question, question number 19. Car moves at a constant speed on snow. Friction is, choice A, 0, choice B, equal to driving, choice C, greater than driving forces, choice D, less than driving forces. According to the given this one, car moves at a constant speed is on the snow. Friction is simply it is what? A constant velocity. Net force is 0. From this one, friction is what? Equals to the applied force. The next question, question number 20, which does not affect the friction force between sliding forces? Choice A, normal force, choice B, surface roughness, choice C, contact area, choice D, materials. From this one, the factors does not affect the frictional between is what? Choice A says that the contact area. From this, for kinetic friction, area does not affect the magnitude or coefficient is independent of the area. So the correct answer is C. The next question is related with 4.3, heuristic conditions of equilibrium, due to we talking or discussing on physics grade 11 chapter 4 about dynamics. Question number 21. For an object in equilibrium, the net force is, according to this one, the object is in equilibrium. Choice A, maximum. Choice B, minimum. Choice D, C, 0. Choice D, equal to weight. When we relate the for an object in equilibrium, first conditions of equilibrium, the sum of all force act on the object is equals to 0. For example, if the object is what? The force is what? Exerted on the object is what? In 3-dimensional means so the total force acted on x-axis, the total force on y-axis, the total force on z-axis is equals to 0. Due to this one, the object is in equilibrium. So the correct answer is C. C is that first conditions of equilibrium. The equilibrium, the net force is equals to 0. The next question, question number 22. A 10 kilogram hanging sign is supported by a vertical rope. Tension in the rope is, choice A, 0 Newton, choice B, 49 Newton, choice C, 98 Newton, choice D, 10 Newton. According to the given this one, the hanging object is what, 10 kilogram by means of what, vertical rope is. So the vertical rope means the force which is pushing up, and the weight of the object is what, the force which is pushing the object downward. Is we have two forces which act in a different direction. When the rope is upward and the weight is downward, let we take the upward as a positive and the downward is as a negative. Means the tension is as a positive, means positive tension minus the weight of the object is equals to 0 from the given this one. When we add both sides mg or mass weight of the object from the given this one, tension is equals to g means mass of the object times gravitational field strength, or 9.8 meter per second. The product of this one is equals to 98 Newton. So the correct answer is C. The next question, question number 23. If a 15 Newton box rests on the table, the normal force magnitude is, choice A, 0 Newton, choice B, 50 Newton, choice C, 100 Newton, choice D, 25 Newton. From the given this one, we have object which is resting on a given surfaces, and we comparing the force of what the normal forces. According to the given this one, the equilibrium, the normal force is the force which is what, pushing upward, and the weight is what, downward. So the normal force is equal with what, the weight, and weight is equals to 50 Newton. So the correct answer is B. B means 50 Newton. The next question, question number 24. Two ropes pull cart, one with 100 east, other 100 Newton west. The net force is, choice A, 200 Newton, choice east, choice B, 0 Newton, choice C, 200 Newton west, choice D, 100 Newton east. From the given this one, we have two ropes, pulls, carts, one with 100 east direction, the other is what, 100 Newton, the west direction. According to the given this one, we have equal in opposite forces. So due to the forces act in different direction, the resultant of this one is what, 0 net forces, and the object is equilibrium. So the correct answer is C. The next question is question number 25. A 2 kilogram object is in equilibrium, which is possible. According to this one, we have what, 2 kilogram object in this situation is what, the object is in equilibrium. So which possibility? Choice A, moving at 10 meter per second. Choice B, accelerating at 2 meter per second square. Choice C, speeding up. Choice D, slowing down. According to the given this object, if the given mass is in equilibrium, what is the possibility from this one? Situation equilibrium means the total force exerted on the object is equals to 0, means acceleration is equals to 0, and constant velocity including 0 or at rest. So this is what the correct answer is. The correct answer is what? The correct answer is A. The next question, or question number 26. Question number 26 says that a lamp of mass 5 kg hangs from a ceiling by a cord. Tension is 49 Newton, B, 5 Newton, choice C, 98 Newton, choice D, 0 Newton. From the given this one, we asked the lamp of mass, which is equals to 5 Newton. So from this one, the cell by the cord is simply, which is directly related with what? The weight of this object is, means 5 Newton times 9.8 kilogram. The product of this one is 49 Newton. So directly the correct answer is what? 49 9 Newton. So the correct answer is what? A. Next question, or question number 27. Question number 27 says that if a 30 Newton is upward force and 30 Newton downward forces act on a book. According to this one, 30 Newton is upward act and 30 Newton is what? Downward. The net force is choice A, 60 Newton, choice B, 0 Newton, choice C, 60 Newton downward, choice D, 30 Newton upward. From the given this one, we have equal forces which act in opposite direction. So the correct answer situation, force is what cancel with each other. The upward we take as a positive one, the downward we take as a negative one. So 60 Newton, 30 Newton minus 30 Newton is equal to 0. Due to the forces cancel with each other, the total force exerted on this object is equal to 0. Due to this one, the correct answer is B. B says that 0 Newton. The next question, question number 29. A 40 Newton child sits on swing, tension in each of the two vertical rope, ignoring rope weight, is choice A. Choice A says that 40 Newton each. Choice B 20 Newton each. Choice C 80 Newton each. Choice D 10 Newton each. From the given this one, we know the weight of the child is 40 Newton and the tension is what? 2 vertically rope is. So the correct answer from this one, 2T means 2 rope is pulling upward, which is equals to 14 Newton. To get the values of this tension, we have to divide this side over 2. This side is also, as I try to showing on the screen, 40 divided 2, which is equals to tension is equals to 20 Newton each. So the correct answer is B. B says that 20 Newton each. The next question, or question number 29. A traffic light hangs from the two cables at equal angles. If the tension each is 100 Newton, the vertical component each is equals to, equal to 17.7. The total upward is equal to choice A 141.4 Newton, B 100 Newton, choice C 200 Newton, choice D 70.7 Newton. From the given this one, when we come to the solution, the situation, the total upward is equals to twice of what? Twice of the given, means 2 times 70.7 Newton, which is equals to 141.4 Newton, equal to the weight of what? The equilibrium. When we go to the next question, or question number 30. A book is pushed against a vertical wall with a horizontal forces of 20 Newton, but does not fail. Friction is equal to its weight as 10 Newton. The normal force is choice A 10 Newton, choice B 20 Newton, choice C 30 Newton, choice D 0 Newton. From the given this one, the normal force, the given normal force is what? The frictional force equal to its weight, which is equals to, let me show you once, from the given this one, the weight of the frictional force is what? 10 Newton, and the force, the normal force is equals to, normal force is equal applied the horizontal forces, which is equals to 20 Newton vertical frictional balancing with each other. The next question, or 4.4, work, energy in power. Still we discussing on physics grade 11 chapter for about, you answer with me, 4.4, work, energy in power. Question number 31. Question number 31. Work done by a constant force is 0 if choice A, force and displacement are perpendicular with each other. Choice B, force and displacement parallel. Choice C, displacement is large. Choice D, force is large. From the given, the idea is say that work done by a constant force is equal to 0 if the possibility is what? From this situation, we know, as we discussed in the class, the work done by a given applied force is the product of the applied force times the displacement of the object times cos theta. According to the given this one, the force in the displacement is what? Perpendicular. Means the angle between the applied force and the displacement is 90 degree. Due to the cos of 90 degrees 0, we insert the values of what? 0 into this cos of 19, 0, f force times displacement times 0, which is equals to 0. Due to this one, the work done on this object is equals to 0. So the correct answer from this one is what? A. A says that a force in displacement are perpendicular. In this situation, the work done on a given object by the applied force is equals to 0. Let us go to the next one, or question number 32. A 10 Newton force moves a box 5 meters in force direction. According to this one, 10 Newton force is exerted, and this force is push the object in the directions of the applied by 5 meters. So the work done is directly choice A 2 joule, choice B 50 joule, choice C 50 joule, choice D 0.5 joule. From this one, when we insert the given value into the equations of what the work done is given, work done is equals to force times displacement. The applied force is what? 10 Newton. The displacement moved by the object is what? 5 Newton. This is the product of this one. 10 times 5 is equals to 50, which is equals to, the correct answer is C. The next question, or question number 33. Question number 33. A 50 kilogram person climbs stairs 10 meter high. The height of this climb is what? 10 meter high. Working against gravity, or the potential energy of this body at this height, choice A, 500 joule, choice B, 4,900 joule, choice C, 50 joule, choice D, 5 joule. When we go to the solutions of this, or the potential energy of this one, the potential energy is directly the product of mass of this times gravitational field strength and times height of the reference. From this one, inserting the given value to the equation, 50 kilogram times gravitational field strength 9.8 times 5 means the height, which is equals to 4,900 joule. So the correct answer is B. When we go to the next question, or question number 34, a machine does 200 joule works in 4 seconds. Power is equals to dash. Choice A 800, choice B 50 watt, choice C 200 watt, choice D 0.2 watts. From the given, we ask the power of the machine, to get the power of the machine, we have to know the work done, or the energy transferred, and in what second. From this one, as I try to show you, power is equals to work done over time. Instead of this W, we have 200 joule. Instead of the time, we have 4 seconds. Inserting the given value into the equation, finally, 200 divided to 4 is equals to 50 watts. So the correct answer is B. The next question, or question number 35. Question number 35 says that a 1000 watt motor runs for 10 seconds. Energy transferred is dash. Choice A 100 joule, choice B 10,000 joule, choice C 1000 joule, choice D 0.01 joule. From this one, we know the power of the motor, and also we know the time. Simply situation, energy is the product of power times time. Power is 1000 and time is 10. When we start given into the equation, the energy transferred is equals to 10,000. So the correct answer is B. The next question, question number 36. If a force and displacement are in opposite direction, work is probability, choice A, positive, choice B, 0, choice D, negative, choice C, negative, choice D, maximum. From this one, the force in displacement is opposite, means the angle between the displacement of the object and the applied force is 118. As I try to show in here, situation, cos of 18 is equals to minus 1. Simply, from this one, the probability work here is what? Negative. So the correct answer is what? C. The next question, or question number 37. Lifting a force here, lifting a 2 kilogram book 1.5 meter high using gravitational field strength is 10 meter per second square. The work done is dash. Choice A 3 joule, choice B 30 joule, choice D 0 joule, choice A is choice D is what? 1.5 joule. From the given this one, when we come to the situation, work is equals to the product of the given this one, mass of times height times what? Gravitational field strength, which is 2 times 10 times 1.5 is equals to 0, 30 joule. So the correct answer is B. The next question, question number 38. Pushing a wall means no movement. According to the given this one, when we clue no movement, thus choice A, positive work, choice B, negative work, choice C, 0 work, choice D, infinite work. From the given this one, the situation, the correct answer is what? C. C says that displacement is equals to 0. Due to this one, due to displacement is equals to 0, the work done is also equal to 0. The next question, or question number 39. A 60 watt bulb uses energy for 1 hour. Energy in this joule is equal to dash. From the given this one, we know the watt means what the bulb uses what? 60 watt is, and the time for this one is what? 1 hour, and simply the energy is equals to choice A 60 joule, choice B 216,000 joule, choice B 3016 joule, choice D 1 joule. To answer this one, we have to know the time. We have to convert the given time into the appropriate unit. 1 hour is equals to 3600 seconds. From this one, the energy is the product of what? The time times what? The energy bulb from the power from this one, 16 watt times 3016 second, which is equals to 216,000 joules. So the correct answer is B. The next question, or question number 40. Unit of power, choice A joule, choice B Newton, choice C watt, choice D kilogram. As we discussed the class, the unit of power is watt. Power is equals to joule over second. From this one, it is what? Power watt. So the correct answer is what? C. The next question, or about the 4.5 conservations of mechanical energy. Question number 41. A 1 kilogram ball is dropped from the height 5 meter high, speed just before ground, using gravitational field strength is 10 Newton, 10 meter per second square. No air resistances. The correct answer, choice A 5 meter per second, choice B 10 meter per second, choice C 7.07 meter per second. Choice D, 14.414 meter per second. To answer this question, the potential energy is a product of mass of the object times gravitational field strength times height, which is equal with the kinetic energy, means half mv square. Due to the object is what is the same in both sides, masses cancel with masses, and we have what gravitational field strength times height, which is equals to 1 over 2 mv square. Appropriately, when we rearrange this equation, final velocity is equals to the square root of 2 times gravitational field strength times height, which is equals to the square root of 100 meter square per second square, which is equals to 10 meter per second. From this one, the correct answer is B. When we go to the next question, or question number 42, a pendulum at a high point has, choice A, maximum kinetic energy, minimum potential energy. Choice B, minimum kinetic energy, maximum potential energy. Choice C, kinetic energy is equal with potential energy. Choice D, zero total energy. From the given this one, at the maximum height, the pendulum has what? At height point, the pendulum has what? Maximum height, maximum gravitational field strength, so which is equals to maximum potential energy. At the maximum height, due to the final velocity is equals to 0, zero kinetic energy. The next question, or question number 43. A 2 kilogram mass at 10 meter high using gravitational field strength is 9.8 meter per second square has potential energy is equals to 196 joule. Choice B, 20 joule. Choice C, 98 joule. Choice D, 200 joule. According to the given this one, we know the mass of the object is 2 kilogram, and the height is what? 10 meter. 10 meter. Gravitational field strength is 9.8 meter per second. Simply inserting the given value into the equation, in situation, potential energy is the product of mass times gravitational field strength times height of the object, which is equals to 196 joules. The next question, or question number 44. A roller coaster at the bottom of hill has, choice A, maximum potential energy, minimum kinetic energy. Choice B, minimum kinetic energy, maximum potential energy. Choice C, maximum kinetic energy, minimum potential energy. Choice D, equal kinetic energy in potential energy. When we go to the solution, this question, at the asked this one, there is what? There is what situation at the bottom or lower highest minimum potential energy in maximum speed, due to this one maximum kinetic energy according to the given this one. The next question, question number 45. A 0.5 kilogram ball throwing up with a speed of 20 meter per second. Maximum height, gravitational field strength is equal to 10 meter per second square. Choice A, 40 meter. Choice B, 20 meter. Choice C, 10 meter. Choice D, 5 meter. And simple, when we come to this one, we asked about what? The kinetic energy. This kinetic energy is given by what? Half mass times velocity square, which is equals to the potential energy, which is mass times gravitational square times gravitational field strength times what? Height. Due to the object is the same, mass is cancelled in both sides. From the given this one, height is equals to the square of velocity over what? 2 times gravitational field strength, which is equals to 400 over 20, which is equals to at 20 meter. So the maximum is what? At 20 meter. The next question, question number 46. In a frictionless slide, a child loses 500 joule of potential. Choice A, gain in kinetic energy is equals to, choice A, 0 joule. Choice B, 250 joule. Choice C, 500 joule. Choice D, 1000 joule. From the given this situation, change in kinetic energy is equals to negative of potential energy, which is 500 conservation of what? Mechanical energy. Due to this one, the correct answer is C. Next question. Question number 47. A spring at maximum compression has choice A, maximum kinetic energy, minimum elastic potential energy. Choice B, minimum kinetic energy, maximum elastic potential energy. Choice C, kinetic energy is equal with what? Elastic potential energy. Choice D, zero total energy. From the given, this spring maximum compression has, it is in this situation, maximum compression is maximum elastic potential energy. Speed is zero. Due to this one, minimum kinetic energy. When we come to the next question, question number 48, the total mechanical energy is conserved only if, choice A, only conservative forces act. B, friction presents. Choice C, air resistance is present. Choice D, normal force does not work. From the given this one, the total mechanical energy is conserved if and only if situation only conservative forces, means gravity, spring, etc. no energy loses. Next question, or the last point, is about what? Physics grade 11, chapter 4, 4.6, impulse in linear momentum. Question number 49. A force of 10 Newton acts on 2 kilogram object for 3 seconds. Impulse is equals to dash. Choice A, 6 Newton times second. Choice B, 30 Newton times second. Choice C, 10 Newton times second. Choice D, 5 Newton times second. As we discussed in the class, impulse is simply the product of force times change in time. So according to the given this one, we have force. Force is equals to 10 Newton and time is what? 3 seconds. So the product of 10 Newton times 3 seconds is equals to 13 Newton times second. Change in momentum. The last question. Question number 50. A 0.2 kilogram ball moving 10 meters per second hits a wall and rebounds at 6 meters per second opposite direction. Change in momentum magnitude. Choice A, 0.8 kilogram meter per second square. Choice B, 3.2 kilogram meter per second. Choice C, 2 kilogram meter per second. Choice D, 1.2 kilogram meter per second. From the given situation, we have change in momentum is equals to mass in bracket final velocity minus initial velocity, which is equals to the given mass is 0.2 kilogram in bracket minus 6 minus 10, which is equals to minus 16. 0.2 times minus 16 is equals to minus 3.2 kilogram meter per second. So the magnitude is 3.2 kilogram meter per second. So the correct answer is from the given B. In general, today we're discussing on physics grade 11 chapter 4 dynamics related questions from 1 up to 15. This is very essential for student learning grade 11. Also very essential for student learning in grade 12 is for preparing what the exam. If you have any question, suggestion, please follow me. Har'a kana walii wajjin ilaallee walumaa gala fiiziksii kutaa 11 boqonnaa 4 jalatti gaaffilee hedduu ilaallee jirra. Kanaaf barattoonni afaan Oromoo dhageessanii miidiyaa yookaan sooshaal miidiyaa kana sooshaal miidiyaa maqaa Itiyoo Fiiziks Global Akaadaamii jedhu kana hordofuudhaan barnoota gara fuula duraatti isin qopheessu qormaataa fi akkasumas immoo qormaata dareetti kan isin qopheessu hordofuu dandeessu jedheen isin affeera. በዚህ ቪዲዮ ያየነው 11ኛ ክፍል ፊዚክስ ቻፕተር 4 ነው። ይህ ጥያቄ በጣም ለ11ኛ ክፍል ተማሪ ይጠቅማቸዋል ብዬ አስባለሁ። እንዲሁም 12ኛ ክፍል ተፈታኝ ተማሪዎችም እንዲሁ ይጠቅማቸዋል ብዬ አስባለሁ። ቪዲዮውን ከወዳችሁ ፎሎ አድርጉኝ። አመሰግናችኋለሁ። ስለ ተከታተላችሁኝ አመሰግናችኋለሁ። ቻው ቻው።